For 6.3, we're going to graph exponential and logarithmic functions. So we'll start by making a table. And for convenience, I'll use the x values -1, 0, and 1. So for every exponential function, we look at the base to find out the parent table. Since this has a base of 2, we're going to evaluate the function f of x at each of these x values to determine the y values. Recall that any number b to the power negative x is equal to 1 over b to the power x. Negative exponents take the reciprocal of a function. So 2 to the power -1 is 1/2. 2 to the power 0 is 1, and 2 to the power 1 is 2. All exponentials have a horizontal asymptote of x equals 0, unless we transform. Oops, I'm sorry, that's y equals 0. Okay, so let's graph. This exponential function has a horizontal asymptote at y equals 0. And that's right along the x-axis. So we'll plot the points -1, 1/2, 0, 1, and 1, 2. So the exponential function gets infinitely close to this horizontal line and then grows. Okay? This grows or increases from left to right. Since the base is bigger than 1, this is a growth. Now let's take a look at this one. Note the base is 1/2. That means this is going to be decay. So we'll start by making our parent table, and we're going to always use the values for x at -1, 0, and 1. So we will plug in these x values into the base function to determine the y values. So 1/2 to the power -1, well, when we do the -1 exponent, we take the reciprocal. So y is 2. 1/2 to the power 0 is 1. Anything to the power 0 is 1. And 1/2 to the power 1 is 1/2. And this has a horizontal asymptote of y equals 0. So let's go ahead and graph this function. Like the previous one, there is a horizontal asymptote at y equals 0. Now we'll plot the points, -1, 2, 0, 1, and 1/2. Like before, this is going to get infinitely close to the horizontal asymptote and go up. So this function is decreasing as we go left to right. And that's because the base is less than 1. So this is decay. This exponential function has been transformed. So let's first identify the transformations. This -4 is on the outside of the function. That tells me that it goes down 4. So this has been transformed down 4. So let's make the parent table. The parent table is 1/2 to the power x, or uses the function 1/2 to the power x. Okay, so we're going to use the x values -1, 0, and 1, and we'll plug these in for x. So 1/2 to the power -1 is 2. 1/2 to the power 0 is 1, and this is 1/2. And the horizontal asymptote is y equals 0. Okay, so now let's make our transformation. So we have our x values and our y values. When we make a transformation of down 4, that has an impact on the y values. So what we're going to do is we're going to subtract 4 from all of the y values. There are no left or right transformations, so the x values will remain the same. So we'll just add 4 to all of the y values. I'm sorry, subtract 4 from all of the y values. So 2 minus 4 is negative 2. 1 minus 4 is negative 3. And a half minus 4 is negative 7 over 2. The horizontal asymptote is impacted by this down 4. We're subtracting 4 from all of the y values. So we'll subtract 4 from the y equals 0, and we end up with y equals negative 4 as our horizontal asymptote. So let's go ahead and graph this. First, we'll graph the horizontal asymptote. So our horizontal asymptote is y equals negative 4. And then we'll go ahead and plot these points. Negative 1, negative 2. 0, negative 3. And 1, negative 7 halves. Well, negative 7 halves is negative 3.5. So the graph is going to get infinitely close to our asymptote. And this is decreasing as we go from left to right. And that makes sense because b is less than 1. This is decay. And so here we have our transformed function. Now let's take a look at this one. Well, this one has the value e in it. So how would we graph this? Well, we're going to have to use our calculator to make some approximations. But the parent function is y equals e to the x. Now recall that e is approximately 2.71828, etc. So since the base is bigger than 1, this will be growth. As always, we will use the x values, negative 1, 0, and 1. And so we will plug these into our parent function to determine the y values. So let's go to our calculator. And you'll notice over here, above the ln button, is the e to the x. So I'll press second ln. And we want to evaluate this at negative 1. So when x is negative 1, e to the x is about 0.4. When x is 0, e to the 0 is 1. Anything to the power 0 is 1. So y equals e to the power 1. When x is 1, e to the 1 is e. So this is going to be about 2.7. And this has a horizontal asymptote of y equals 0. Okay, now let's make our transformations. So what transformations do we see here? This transformation is inside the function. So that corresponds to left 3. This transformation is outside the function. So that corresponds to up 2. So when we make our new table, what we're going to do is we are going to subtract 3 from the x values because we went left 3. And we are going to add 2 to all of the y values because we went up 2. So negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. And 1 minus 3 is negative 2. Now we're going to add 2 to the y values. So this is going to be 2.4, 3, and 4.7. Now this also has a horizontal asymptote, and we're adding 2 to the y values. The left and right translation does not have any effect on a horizontal asymptote. So our new horizontal asymptote is going to be y equals 2. So we'll start by drawing in our horizontal asymptote. Our horizontal asymptote is y equals 2. And then we'll plot our points. Negative 4, 2.4 is about there. Negative 3, 3 is about there. And negative 2, 4.7 is about there. So our graph is going to get infinitely close to the horizontal asymptote, and then it's going to go up. This is increasing from left to right, which makes sense because our base is e, which is bigger than 1. So this is growth. Now let's try graphing the log function. So y equals log base 2 of x. There are no transformations here, so we're just going to graph the parent function, which is log base 2 of x. So we'll start out by making our parent table. So recall that the log is the inverse of the exponential. The log is the inverse of the exponential function. Okay, so to find the inverse, we switch x and y. So since this has a base of 2, that means our exponential had a base of 2. So I'm going to write what we normally put as the x values as the y values. So our y values will now be negative 1, 0, and 1. To find the x value, we simply raise the base to the power of the y value. So 2 to the power negative 1 is a half. 2 to the power 0 is 1. And 2 to the power 2 is 2. Now, since the exponential has a horizontal asymptote, that means the log is going to have a vertical asymptote of x equals 0. So we'll go ahead and graph this. This has a vertical asymptote of x equals 0. We'll plot the points. 1/2, negative 1, 1, 0, and 2, 1. Our function is going to get infinitely close to the vertical asymptote, and then it will grow and sort of flatten out. So this is our log function. Let's check out another one. This log doesn't have a base. Well, recall that this is a common logarithm, which means the base is equal to 10. So there are no transformations. No, so let's draw our table, our parent table. So since the log is the inverse of the exponential, negative 1, 0, and 1 are going to be our y values. To find the x values, we will evaluate the base, which again is 10. at each of these corresponding y values. So 10 to the power negative 1 is 1/10. 10 to the power 0 is 1, and 10 to the power 1 is 10. This also has a vertical asymptote at x equals 0. So we'll start by plotting our vertical asymptote, which is right on top of the y-axis. And we'll plot our other points. -1, 1/10, which is very close to the x-axis. 1, 0. Oops. Yep, that was right. Sorry, I got that backwards. 1/10, -1, which is right here. 1, 0, which is here. And 10, 1, which is way over here. So again, this is going to get infinitely close to our vertical asymptote and then kind of flatten out. Okay, so that is our log. So let's identify the transformations of this function. This has been vertically stretched by a factor of 2. This +4 is on the inside of the function. So that means we've gone left 4. There is no up or down in this example. So our parent function is y equals log base 1/2 of x. So we'll go ahead and make our parent table. And the y values are going to be -1, 0, and 1. So to find the x values, we're going to evaluate the base to the power of y. So 1/2 to the power -1 is 2. 1/2 to the power 0 is 1. And 1/2 to the power 1 is 1/2. This has a vertical asymptote of x equals 0. So let's make our transformations. This vertical stretch is going to multiply the y values by 2. The +4 on the inside means we are going to subtract 4 from the x values. So if we subtract 4 from the x values, we end up with -2, -3, and -7/2. Now we're going to multiply the y values by 2, so this becomes -2, 0, and 2. Now our vertical asymptote is affected by transformations up to the x values. So shifting this to the left 4 means our new vertical asymptote is x equals -4. So we'll start out by graphing our vertical asymptote, which is at x equals -4. And then we'll plot our points. -2, -2, -3, 0, and -7/2, which is -3.5, and 2. So this is going to get infinitely close to our vertical asymptote, and then come on down this way. Let's do one more. First, let's identify the transformations. This negative here means that this has been reflected over the x-axis. This 3 here represents a vertical stretch of 2. Oops, of 3. Okay, so let's first identify the parent. The parent function is log base 2 of x. So we'll make our table with y values, -1, 0, and 1. And so the x values are going to be 2 to the power -1, which is a half, 2 to the power 0, which is 1, and 2 to the power 0, which is 2. And this has a vertical asymptote of x equals 0. Now let's make our transformations. The reflection and the stretch both impact the y values. So we can do them both at once. We will multiply the y's by -3. So the x values are unaffected. The y values are multiplied by -3. So 3, 0, -3. The vertical asymptote is also unaffected because transformations to the y variable do not have any effect on the vertical asymptote. So we'll start by graphing our vertical asymptote, which is right here on top of the y-axis. And then we'll plot our points. 1/2, 3 will be here. 1, 0 is here. And 2, -3 is here. So this gets infinitely close to the vertical asymptote, and then it just kind of comes down here. The graph can never cross the vertical asymptote. That's everything for 6.3. I will make another video with some extra examples.